Hello, my name is Jason Bondarchuk, and here is my project submission for Project 3. First, I will show the output of the forest fires dataset on each of the networks. First, we'll show the linear network. Okay, so here are the values, and this is the overall error. Next, I will show the feed-forward neural network. Here's the predictions, and here's the average error. Lastly, I will show the auto-encoded neural network. Here are the predictions, and here's the overall error. I will now show forward propagation for the linear regression network. In linear regression, forward propagation is just the weighted sum, find the dot product between the input and the weights plus the bias, and our output was 0. Next, I will show forward propagation for the logistic regression network. First, we calculate our softmax predictions. To do this, we load our input into the input layer. Next, we calculate the weighted sums. It returns the bias plus the weighted sum. Using the weighted sums, it calculates softmaxes. Softmax is calculated as the exponential function of each output node divided by the sum of the exponential functions calculated for all output nodes. The final outputs are our softmax values. Now I will show forward propagation for the feed-forward neural network. First, we load the data row into the input layer. Then, for each layer, we calculate the propagate forward method. First, it calculates weighted sums for each neuron. Next, it calculates any optional nonlinear functions. For hidden layers, we calculate the logistic function. Here's the calculation for the logistic function. Softmax is calculated in the same way that it was calculated in the logistic regression. Linear regression output layers do not have a nonlinear activation function. The method runs until all nodes in all layers have finished calculating their output. Next, I will show you the auto-encoded network. The first network is the autoencoder. As we can see, the feed-forward function is the same as the feed-forward neural network. The calculations are the same. Next, we have the full auto-encoded network. This also uses the same feed-forward function. As we can see, this should run. The neuron class is the same for all nonlinear neural networks. I will now show the weight updates for linear regression. It calculates a delta weights value. After the iteration over the entire dataset, it calculates the updates in weights. Next, I will show the weight update rule using logistic regression. The same as before, we calculate all of the delta weights for each of the output nodes. Our weight update rule is the learning rate times the delta weight divided by the size of the dataset. We can see our weights updated here. Next, I will show the weight updates for feed-forward neural networks. Keep in mind this is the same as the autoencoder and the autoencoded network. Backpropagation will first iterate over each layer, starting at the last layer. The first case is backpropagating through the output layer. First, it calculates the derivative of the loss function. To start, the bias is set to the derivative of the loss function. Next, it calculates the derivative of the loss function with respect to each weight. The second case is if it's a hidden layer. It calculates a summation. The summation's inner function is each immediate downstream node's partial derivative. We can see that summation here. In this neural network, all hidden nodes use the logistic function, so we need to multiply by the logistic function's derivative. This is equal to the logistic function of x times 1 minus the logistic function of x. Finally, we calculate the partial derivative with respect to each weight. For this single node, we can calculate the delta weights. This is the general update rule for a neuron. I've used this same neuron class in the feed-forward neural network, the auto-encoded network, and the autoencoder. I will now demonstrate how the autoencoder is working. Here, the autoencoder is loading the input as the correct output. Next, I will briefly show the weight updates and backpropagation happening in the autoencoded network. It does not update the autoencoded layer. But here is the calculation of the weight updates. I will demonstrate the autoencoder recreating the input. Here is an example given from the final iteration of gradient descent.